So in this session we are going to cover what are type of control instructions, decision control structure, loop control structure, case control structure, use of break and continue. We'll be writing some programs and I'll be giving you some questions that you can try it out at your own place. So let's get started. So types of control instructions. So in C we have basically three types. One is decision control structure. Decision control structure is driven by some action, some event that has happened, and based on the result of the event, what action that I have to take. For example, if I get pass marks in mathematics test, I'll be getting candies. If I don't get pass marks in mathematics test, I'll be not getting the candies. So the event is passing of mathematics test. The action are two different actions, whether I'll be getting candies or I'll not be getting candies. So these kind of statements or these kind of flows comes under decision control structure. Loop control structure. Loop control structure basically comes under events where we require actions more and more than one time. For example, I want to print a table of 10. So what I have to do, I have to do calculations like 10 into 1, 10 into 2, 10 into 3. I need to do it 10 times. So there are two approaches. One basic approach is like I will write those 10 statements and print my output. So what is the disadvantage of this? Because every time if I want to change the number of times, suppose I want to print till 10 into 20, then again I need to write all the 10 instructions again and again. Instead, if I can use a loop, I just need to loop it around the given number of times. For example, if I have to write a table from 1 to 10, I can loop it 10 times. If I want to write a table from 1 to 20, I can loop it at 20 times. So this gives me more control over my program. So for these kind of things, loop control structures are used. Case control structures are used for decision making. These are the special type of decisions making structures where the event can have more than one output, and we need to take action on each and every output. So using case control structures, we can write a code for these kind of behaviors. So let's see about decision control structure. So as we have discussed earlier, when we want to set when we want a set of instruction in one situation and entirely different set of instruction in other situation, we use decision control structure. In decision control structure, we have if statement, we have if else statement, we have nested if else statement, and conditional operator. So what is if statement? Let's see one flow chart of if and else control statement. We'll be entering to our program in this manner. This is symbol of decision making. So condition to make decision. So earlier I have given an example of passing in the mathematics test. So I can say a result of my mathematics test. True means I passed, false means I failed. So in case of true, I'll be getting candies. In case of false, I'll be not getting the candies. So how we write in our C program? So we write it if condition, then statement or block of statements. So in this, it can be either one statement or many statements. That's why we have written block of statements. Okay, so let's try it out. Let's do some dry run of this code. Let's predict what should be the output of this program. Okay, so I am declaring a variable a equal to 0. I will be entering a number. Okay, user will be giving me a number. If a is greater than 0, I'll be printing a is a positive number and return 0. So what this program is doing, it accepts one number from the user and check if the number is positive or not. Okay, so let's write a code for this. Okay, let's create a file. Okay, program to check if number is greater than 0 or number is positive. Let's include stdio.h hash include. Let's write the main method. So we will return 0. Okay, now let's declare one integer a. Okay, let's printf enter the number to be checked. Scanf %d %a. So we'll be getting a in this. Okay, here I missed double quote. Okay, now I'm writing if a is greater than 0, then print this statement. Yes, the given number is than 0. Okay, else number is not greater than 0. Okay, let's do one printf so that we differentiate between our output. /n. Okay, let's save it. Let's compile it. Okay, compilation is success. Let's run it. Okay, enter the number to be checked. I entered 3. It says yes, the given number is greater than 0. Let me run it again. I'll give -4. Say no, the given number is not greater than 0. So this is how we use if statement here I have used if and else, so both are related. Like if you don't use else statement, then it is considered that you don't want to do anything if the condition is false. So but it is better if you write else statement, so that in case if your logic does not want you to do anything in else statement, let's keep it empty. It would be more clearer, and in future if you want to use it, you can write some code on this, or you can have some printf in the else statement saying that the condition was false, so so else statement is printed. So this will be helpful while doing the debugging. If anything is not correct and you are debugging, you can check the logs and see, okay, why your program is misbehaving. So it's good to have else condition. Okay, so this is the if and else condition that we have covered in the example. So if condition statement 1, else condition statement 2. So in the code that we have written, we have checked if a is greater than 0, then statement 1 is executed. The statement 1 was printf here, yes, the number is greater than 0, else printf, no, the number is not greater than 0. Okay, so here is one more example. Write a program to determine if a given number is even or odd. So this program is much more similar to what we have already written. We'll be having a number, we'll be declaring an integer variable and getting it from the user, and checking if the modulus or modular operation of the number by 2 is giving 0. If yes, then we say that number is even, else we'll say the number is odd. So this is a complete code. I'll like you if you just try it out by yourself and get more familiar with if and else statement. So nested if else statement. Nested if else statement has one extra thing which is called else if. So if condition 1 is true, then statement 1 is executed. If condition 1 is not true, then structure will check if condition 2 is correct. If condition 2 is also not correct, then then the else statement will be printed. Okay, so let's write some code for this. Let me take one example. Okay, let's write a program to check if number is greater than 0, number is divisible by 2. Okay, so we are checking two things here. So let me include stdio.h hash include return 0. Int a has declared one variable, printf, enter the number to be checked, scanf, %d, ampersand a, Okay, now we'll be adding the nested if else condition. If a is greater than 0, then check yes. If it is greater than 0, then we'll be printing out yes, a is greater than 0. Else if, so this will check if a percentage 2 is equal to 0. If it is true, then printf yes, a is divisible by 2, else printf a is neither greater than 0 nor divisible by 2. Okay, let me give one more printf so that our output is clearly visible on the screen. Okay, let me compile it. Minus yes, the program is compiled quickly. Okay, enter the number to be checked. I'll say 4. It says yes, the number is greater than 0. I'll run it again. I'll give -4. So it says yes, number is divisible by 2. So I'll run it again. I'll say -5. So it gives me a is neither greater than 0 nor divisible by 2. So this program checks if a number is greater than 0 or a number is divisible by 2. If not, then print that your number does not fall into the given criteria. Okay. So here is one more example of nested if and else, where we have two numbers, m equal to 40 and equal to 20. If m is greater than n, then it's printing yes, m is greater than n. If it is less than n, then it is printing yes, m is less than n. Else, if these two conditions are not fulfilling, then it says that m is equal to n. So this is also a very simple example. I like you to try it out at your place so that you can get more understanding on the nested if else statement. Okay, the conditional operator. The conditional operator is also known as the ternary operator. The ternary operator, the statement of the syntax of ternary operator is this: we have one condition. If the condition is true, statement 1 will be executed. If condition is false, the statement 2 will be executed. Okay, so and both condition and statements are separated by some delimiters. So question mark and colon are the delimiters here in this case. Okay, so let's write some code for this. Okay, example of ternary operator. hash include stdio.h main method. Let me return 0. Now let me declare one variable int a equal to say 3, or let me have a printf one number checked. Here we'll be checking if the number is divisible by 2. Scanf %d ampersand a. Let's have some ternary condition. Okay, if a percentage 2 equal to 0, then printf number let me give the number %d is divisible by 2, else printf %d is not divisible to a. Okay, given printf this will give me more this will segregate the output. Okay, let me save it and compile it. gcc -o read C. Compilation is successful. Let me run it. Okay, enter number to be checked. I say 5, so 5 is not divisible by 2. Let me run it again. I'll give 4. You say 4 is divisible by 2. So this is how we use the ternary operator. So basic syntax is the condition, then statement in case the condition is true, then the statement in case the condition is false. So this is the if statement and this is the else statement. Okay, so this is the example. Here I have used the same example that we have just written the code for. So loop. Now let's begin with loop control structure. So what are loop control structure? Loop control structure are nothing but the control structure that facilitates the operation that we want to repeat for certain times. C supports 3 type of loop control structure. One is for loop, one is while loop, one is do while loop. So this is just a basic flowchart of how your loop structure will look like. There would be one initialization, okay, and a condition that needs to be tested. If the condition is true, the loop will be continued. If the condition is false, the loop will be ended. For example, if we want to print the number from 1 to 10, I'll be initializing some variable, say suppose int I equal to 0, and check if I is less than 10. If the condition is true, I'll be doing some calculation, or I'll be doing some other stuff. If the condition is not true, I'll be falling into false state. So let's see what is the syntax of for statement. Uh, in for loop control structure, loop is executed till the condition becomes false. So this is the basic syntax of for loop. We have expression 1, expression 2, and expression 3. So expression 1 indicates the initialization of variable, expression 2 indicates condition checking, and expression 3 indicates the increment or decrement of the variable. So here is an example. In this example, we are printing a number from 0 to 9. Hash include stdio.h int main int I. I am declaring I. Now I am initializing I to 0. I am checking I is less than 10 and incrementing I by 1. Here, if this condition is true, I'll be getting inside the loop, and I'll be printing the value of I. So this code will result in printing a number from 0 to 9. Okay, so for while loop, in while loop control structure, the statement also the loop is executed until the condition becomes false. So here's the syntax of while loop. So here the syntax of while loop is while, condition, and statement. So we need to make sure in while loop we need to make sure how we are checking the condition and how we are exiting out of the loop. If we don't do the condition check and if we don't make sure that we are coming out of the loop, we will be stuck up into an infinite loop, and this is really bad. So this is a sample program for writing the while loop. Here I am initializing a variable I equal to 3. I am saying while I is less than 10, I am printing the number and incrementing it. So this is very important, and this is also important. So what will happen? The loop will continue till my value of I will become greater than or equal to 10. If I remove this condition, then I have initialized I is 3. I will always be 3, and the loop will continue endlessly. So to make sure that our loop will exit properly, we should have some logic in place, so that at some point of time this condition should become false and we'll be exiting out of the loop. So do while control structure. In do while control structure, the while loop is executed whatever is the condition for the first time, and from second time onwards the while loop is executed until the condition becomes false or 0. The syntax for do while loop is do, and then we are doing one statement and while condition. So in do while loop, the statement will get executed at least once. So first the statement is executed, then the condition will be checked. In while loop, first the condition is checked, then the statement is executed. So it depends upon our logic whether we want to use a do while loop or whether we want to use a while loop. So here is an example of using a do while loop. Again, I am taking one integer I equal to 1. I am using a do while loop. Do printf value of I is say %d, and then incrementing I while I is less than equal to 5 and I is greater than equal to 2. So for the first time, what will happen? I is 1, this condition will be executed, and then I will be incremented in the at this point of the time, this condition will be checked. whether I is less than equal to 5 or I is greater than equal to 2. So when this part of code is executed, I becomes 2 and this condition will become true. So this loop will be continued, and this will be continued until and unless your I becomes greater than 5. So what I'll be printing? I'll be printing 1, 2, 3, 4, 5. So let's do some let's write some examples or some code for all the loop structures. Okay. Let me include stdio.h. and 0. Okay. Int I. First I am using a for loop. For I equal to 0, I less than 10, I plus plus. Okay. I am printing I. Printing percentage d in for loop. Let me print I. Okay, so this will print the value. Now let me have a while loop. Okay, so I'll be initializing I with 0 again, and so while I is less than 10, okay, printf /n printing percentage d in while loop I, and I'm incrementing I. This is very important. Now let's use do while loop. I equal to 1, 2, printf /n printing percentage d in do while loop I and I plus plus. Let's give a while loop, while condition, sorry, while I is less than equal to 5 and I is greater than equal to 2. Okay, then let me give a printf here, the /n, so that output is clearly visible. Okay, let me run this. Let me compile this code. ECC minus o loop.c. Yes, code is compiled successfully. Let me run this code. So here we got this output. First we have printed 0 to 9 using for loop, then we have printed 0 to 9 using while loop, then we have printed 1 to 5 using do while loop. Okay, I have combined the examples of for loop, while loop and do while loop in one program. So just to make sure how to use these things, so it depends upon your program logic on how you want to make sure how the conditions are executed. Only the iterations will remain the same, like how you want to use the iteration, when you want to check the condition, and incrementing the variables, decrementing the variables, and so on. So case control structure. Case control structure is a special type of control structure where we can check um, one condition for or one event for a multiple actions. For example, if we want to check if a number is greater than 0 or a number is divisible by 2, so we can easily write a very simple if case control structure to solve this. Case control structure has following keywords: switch, break, continue, and go to. We'll be covering this right now. So how we use switch and case. Switch case is substitute for nested if statement. So earlier, if you remember, we have written a program for nested if else statement where we have checked if a number is greater than 0 and or a number is divisible by 2. We'll be writing a same program using switch case statement. The syntax of switch case statement is like this. It will have a switch, then expression, then it will be having a corresponding case statement, then break, case statement, then break, default statement, and then break. So how this is executed, it will check the condition. If the condition matches with any of the label, it will execute the statement corresponding to that label. If any of the case is not matched, it will execute the default statement. Why break is needed? Because if you don't give break here, suppose let's consider this program. For example, we have a program void like this: void main int x, switch x, case 1, case 2, and and default. For example, if x is say 1, I'll be checking for value of x. It falls into case 1 and it prints case 1. And it breaks here. So if I don't give a break here, it will continue the executing the case statement until it finds a break. So suppose if this break is not here, this break is not present, and I give x equal to 1, I'll be printing x is 1, x is 2, and now until and unless it identifies a break. And now this is a wrong way of this is wrong because my value of x is 1 and I'm printing my x is 1, x is 2. So we have to be very careful to use break where we want to use break, what is our logic, and we should be exiting the case statement as and when is required. So this slide explains why we require the break keyword. So let's write some code to understand how switch case control structure works. Okay. Program to understand switch case structure. I'll be including stdio.h hash main and 0. Okay, let me have some integer, say integer x. Let me get it input from user. The value of x scanf %d %x. Okay, let's use switch x case 1 printf x is equal to, or let's check if a number is divisible by 2. So x %2, so case 1 x is not divisible by 2, break. Case 2, case 0 printf x is divisible by 2, break. Let's have a default. It says printf, it says I don't know the output. Okay, let's give a printf here. Okay, let's save it and compile it. So compilation is successful. Let's run it. Enter the value of x. I'm saying 5. X is not divisible by 2. Let's run it again. I am giving, say, 2. X is divisible by 2. Let's run it again. Let me give some negative value. X is divisible by 2. So this is how switch case behaves. Let me modify the program. Okay, so what if I remove this break statement? Let me comment it out. Okay, so let's compile the code again. Let's run it again. Enter the value of x. I say 5. So it gives me two output. X is not divisible by 2 and x is divisible by 2. So if I remove the break, it will execute this condition. Since I have given 5 5% h2 is 1, it executed this condition and it didn't find a break, so it also executed this condition. It finds break here and terminated at this point of time. Let me remove the comments and let me comment out this break. Let's compile it again, run it again, enter the value of x. Let me say 6. It says x is divisible by 2 and it says I don't know the output. Let me run it again. If I say 5, it says x is divisible by 2. Let's revisit our code. So in this case, if I give 6% 2 is 0. It comes here, it says x is divisible by 2 and there is no break, so it will continue till the switch statement ends or it finds any break. If I give 5, then 5% 2 is 1. It came here, this statement is executed and break. So that's how switch case works. So be very careful to put breaks wherever is required, otherwise your program will not give the correct output. So example of using break statement in for loop. So break statement can be used in loops also. In suppose if you want to exit the loop prematurely based on some condition, you can put break and the loop will not be continued. We will be exiting out of the loop and the statement after the loop will be executed. So this is how break in loop work. Continue statement means continue statement will continue the loop, like it will check if some certain condition is true or false. If we put a continue keyword inside a loop and if the loop hits the continuous condition, then what it will do is it will not execute the statement after continue, but it will go to the next iteration of the loop. Loop will not be executed, but it will go to the next iteration of the loop. So for example, in this case we are printing a number from 0 to 9. So if this condition is matched, say I equal to, if I is 5 or 6, we will be skipping the execution of statements where we don't want to execute in case I is equal to 5 and 6. So we have kept continue. So in this place I'll be my output will be 0 1 2 3 4. 5 and 6 will be skipped, 7 8 9. So I'm sorry because this printf is not shown in the output, but yes, this printf will be coming into output. But just to explain how continue works, this is how the continue works. If we don't execute this, if we comment out this print statement, this is the output that I'll be getting. So Goto statement. Goto control structure is used to transfer the control of a program to a specified label of a program. So it is kind of looping, but C has provided Goto, but it is advisable not to use Goto control structures because you never know when your program will going to misbehave. So it's always advisable to use either standard loops like for loop, while loop, do while, or some if else statement, switch case. But I'll advise not to use Goto statement, because that can lead to a very buggy code. Since C support this, so I'll be covering Goto in this lecture. So this is a syntax of Goto statement. We'll be having statements Goto label. So when the statement is executed, when I hit the Goto, I'll be directly going to place where label is there. So this is kind of a looping. From here I'll jump directly here, then I'll be executing this, I'll be jumping here again. This is the example of how Goto is used. So this is a code. Int main, int I equal to I have declared I. For I equal to 0, I is less than 10, I plus plus. If I equal to 4, printf Goto statement when I is 4, say go to label, and in this case the loop will be exited. So if I is not equal to 4, I'll be printing the value. In case I is 4, I'll be exiting out of the loop. So this is how Goto works. So what will be the output of this program? The output will be 0, 1, 2, 3. And when 4 is executed, next line that is printed is Goto statement when I equal to 4, and value of I is 4. This is the output. So let's do some more coding. Let's write some more program. Write a program to print table of a given number. For example, if I am given a number, say 9, I will have to print a table like 9 into 1 equals to 9, 9 into 2 equal to 18, and so on till 9 into 10. So let's write the code for this. Okay, let me include stdio.h and main int I am declaring some variable I, int n, let's get an input from user, enter the number, scanf, %d, ampersand n. Now for loop I equal to 1, I less than equal to 10, I plus plus. I'm printing printf %d into %d equal to %d. Okay, so let me, and slash n next line. Okay, so n into I equal to n into I. Okay, this will be my output. So I have given semicolon after for loop and executing the statement, so this is why I am getting compilation error. Okay, program is successfully compiled. Enter the number, say 9. So this is how I am printing. 9 into 1 equal to 9, 9 into 2 equal to 18, 9 into 3 equal to 27, 9 equal to 4, 36. Let me run it again. Let me give say 16. So I will be getting a table of 16. Let's do one more code. Write a program to find the factorial of any number entered through the keyboard. So how we calculate a factorial? The factorial is calculated, suppose you have number n, so factorial is calculated as n into n minus 1 into n minus 2 up till n 1. So here also we need to do the loop, create a program for this. So we are printing factorial of a given number in this program. Hash include stdio.h int main return 0. Okay, say let me take some variable and then let me get it from user. Printf enter the value of n scanf %d and %n. Okay, now let's take a while loop here. I'll be using one more variable I equal to 1, and I'll be using one more variable, say factorial. So and factorial also equal to 1. Okay, so I'll be writing a loop while I is less than or equal to n. Factorial equal to factorial into I. Let me increment I. Okay, now let me print the output. Factorial of %d is %d. So factorial of n is fact. Okay, let me give one slash n here. So this is how we can calculate a factorial. Let me save and compile. GCC -o. Okay, program got compiled successfully. Enter the value of n, let me say 4. So factorial of 4 is 24. So this is correct. Let me run it again. Let me give say 6. So it is giving me factorial of 6 is 120. So this is how factorial is calculated. Let me run it again. Let me give 5. It will give me 120. So this is how factorial is calculated. We'll be here in this program. We are going from 1 to n and multiplying the factorial every time with I, incrementing I. So, and at the end we are printing the output. Okay, so now I'll be giving you these two exercises. You can try it out at your place. First problem is write a program to print all Armstrong numbers between 1 and 500. So what is an Armstrong number? If a sum of cubes of each digit of a number is equal to the number, then the number is called Armstrong number. For example, 153 equal to 1 into 1 into 1 plus 5 into 5 into 5 plus 3 into 3 into 3. So the cube of every digit, sum of cube of every digit is equal to the same number, then it is called an Armstrong number. So you need to write a code. This will also, you can solve it using one of the loop and using one of the arithmetic operator. Basically you have to use a modulus operator and you can solve this problem very easily. One more program is write a program to print Fibonacci series from 1 to n, where n is received as an input. So what is a Fibonacci series? Fibonacci series is starts with 0, 1, and then the next element will be the addition of previous two elements. So the next element will be equal to 0 plus 1, which is equal to 1. Next element will be equal to 1 plus 1, which is equal to 2. Next element will be equal to 2 plus 1, which is equal to 3, and so on. So if n is given as an input, you need to print the Fibonacci series from 1 to n.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.